Going to take another look at the Viking RC311 vacuum tube radio, old one from the 1950s. I looked at this before. Somebody had been in there and monkeying around with it and bypassed the rectifier tube with the diode, and well, we got it going before, but I've gone through some tubes. I've found some full-wave high vacuum rectifier tubes. So we're going to fix this thing the right way and put it back to stock operation. I had this one apart last year. Well, actually, never apart, because this is how the radio is. This was given to me. Somebody, unfortunately, trashed the cabinet for this radio, gave me the chassis and the speaker, and they used the wooden cabinet to make it into a liquor cabinet. Of all the selfish things to do to destroy an old radio because it didn't work, and rather than have it properly restored so that it's a collector's item into a working state, they pulled the chassis and hacked up the cabinet and turned it into a rather ugly looking liquor cabinet, I will say, because I saw the work that they did on it. But beside the point, it was a floor standing radio originally, just a straight AM radio, no shortwave or anything. But you remember when I looked at this before, the 5Y3 rectifier tube was shot on this one, and somebody had put a diode across the tube, but they hadn't removed the actual tube itself. They hadn't disconnected it from the socket, so the diode shorted. Well, today I'm going to reverse that, because I was going through my collection of old vintage tubes and I found a 5Y3, which I think is probably okay. So I want to keep this thing as original as possible, even though it's just a chassis. I'm hanging on to it as part of my vintage radio collection. I'm going to put the right tube in here. We'll remove that diode and we'll reconnect things. Now, since you guys last saw that radio, I actually borrowed the audio output transformer when I was working on that even older old Electro Home radio, the one that we changed the output transformer on. And I had this one. I used this one temporarily to verify operation, which I've since reinstalled. The transformer's right here. And it's been reconnected because the other one was a single-ended. This is a push-pull, so the two plates have been reconnected on here. I haven't reconnected the B+ line, which is going to go over here to the tube when it's done. And I have to reconnect the two plates. So there's the diode that was put in before. I just put heat shrink tubing across it, and this is where the wire fed out to the transformer, and I just kind of cut it just to take the transformer out. So I'm going to replace the transformer, or rewire the transformer, and we'll put the two outputs from the secondary back onto the two plates, and verify that this thing works with the proper tube rectifier, so that it is once again as it's supposed to be. Now, somebody else has already recapped most of the critical capacitors on this, so I'm not going to have to do anything there. Yes, there's still some old paper capacitors in here, which probably could use replacing, but they're not ones that are in critical places where they're going to burn up tubes, for example. All the ones that deal with the plates and the biases of the tubes, the bypass capacitors like these ones here, these ones have been replaced. That one probably could be replaced there, and maybe that one there. This one's in the tone control. I don't need to worry about that one. I'm not going to replace those at this point in time because this radio is not going to see general service. I just want to rewire the tube socket, verify that the tube is working, and then we'll leave it at that. I'll play it for a bit, and then we'll leave it at that, because it's not going back into general service because I don't have a cabinet for it. But saying that, if I ever find a cabinet that I can put this in, I may just do that. So let's hook up the tube socket. So basically how this works is the two outputs from the secondary, like the secondary coil, goes to the two plates. And it doesn't matter which one that I put it to. Either one. Put it to that one or the other one, doesn't matter, because we're dealing with AC. So there's one wire. The other one is the one that's still connected to this diode. So I'm just going to take the heat shrink tubing off here and disconnect it. Now, this being a direct heated rectifier tube, there is no separate cathode that there would on a different type of rectifier. Would have a separate pin that is the cathode, where your positive lead would go to your filter capacitor and your output transformer, because they have an indirectly heated cathode. This is a direct heated, the 5Y3 is a direct heated cathode. So either one of these can be made the positive terminal. They just have to, both my filter cap and main B plus and the transformer go to the same side. So I could connect them both to there, or I could connect them both to there. It doesn't matter, because this is just an isolated, these two wires here, these just have 5 volts across them, right? This is just the 5 volt heater supply, and they become the B plus. So both of these wires are going to have B plus on them. So it doesn't matter which one I put them to. So I'm just going to put them both to this one down here, which is, I think, where they originally were anyway, right? So that's one wire, and the other one is this one here that's still got the diode on it. We'll take that off. Now you might wonder, what are the advantages to keeping this radio original? Like, what's wrong with having the rectifier diode in? Because hey, it's just a rectifier, right? Who cares whether it's a tube rectifier or a silicon rectifier? Well, the big difference is the performance. A diode is much more efficient than a tube at rectifying. So even though it's, and this is a full wave rectifier also, right? The tube itself is a full wave rectifier, whereas a single diode is just a half wave rectifier. But I could put 2 diodes in and it would have a full wave rectifier. The big reason why you want to try and keep this thing original, other than, you know, from an aesthetics and just a historical perspective, to keep the circuitry original, but the diode is a lot more efficient, which is going to result in a higher voltage to the B plus, to the capacitor, and all the other circuitry. The other problem with the diode is that, being a solid state device, as soon as the power is switched on, that diode is rectifying, and you're going to have your high voltage come up instantly as soon as you turn on the power. And charging capacitors to 400 volts instantly is not good. Hammering them with full B plus. But you're also hammering all the plates of the tubes with full B plus, and the tubes themselves haven't warmed up yet. So using a tube rectifier in a tube radio such as this, the B plus will come up slowly as the tube warms, and of course the rectifier tube is heated at the same time as the indirectly heated cathode for all the other tubes. It's going to warm up faster, so the high voltage is going to come up slightly faster than the rest. But at least the high voltage is going to come up slowly. It's not going to come on instantly. It's going to come up as the filament heats up, and it's also going to come up at a slower rate along with the rest of the tubes, which are also warming. So as far as reliability goes, it's going to increase the reliability of the other components, just in the fact that they're not going to get hit with high voltage. Now, reliability wise, as to how long the tube is going to last, well, a rectifier tube, being a tube, is going to eventually wear out, and hopefully this one that I put in is good. So I figured we'd look at the technical data for the 5Y3 GT. I think this one is, yeah, GT tube. This is the dead one. But we'll go over some of the specs on this thing. Another popular tube was the 5W4, which is this one here. And the big difference between the 5W4 and the 5Y3 is the filament current. It's 1.5 amp current versus, so the 5W4 is a 1.5 amp current filament, whereas the 5Y3 is a 2 amp current. Where did I see that here? Here we go. 5Y3. So the current for the filament is 2 amps. So you might be able to get away with using a 5W4 rectifier in place of a 5Y3 because it's less current. I think the Pin 2 and 8 are the filaments. Yeah, the same plate, and 4 and 6. So pin-wise, the 5W4 is the same, except for it has less current handling capability than the 5Y3. So I have a 5W4 as well, which I could have used in here because they're both a full wave rectifier. This one here that failed in here was a Marconi. It was made in Canada. But I mean, if we look at the date on this, it gives you an idea what the age of this is. These tubes were in production in 1951, and so they're relatively old. The 5W4 is an older tube. As you can see, it's a 1941 design, so a little older, but not as high a current capability. If we look at the 5W4, it has a maximum AC plate voltage of 500 volts and 300 milliamps, and the voltage drop at 100 milliamp is 45 volts per plate. And this one here are plate current 400, or peak plate current per plate 400 milliamps versus 300 milliamps. So the 5Y3 is a higher power tube. It's a 400 milliamp tube versus a 300 milliamp. In this radio, probably we would have been fine. Although this is quite a high tube count radio, right? The more plates you've got, the more current you're going to need. So we may find if we're going to put a 5W4 GT into this radio here, we may find that the voltage is a little bit on the low side, just because they don't have the current handling capability on that proper tube does have. Here's how the tube is connected in the set itself. So you've got two windings. You got your 120 volt winding here, and then you get your high voltage winding with a center tap, and you've got a 5 volt winding for the filament. The center tap of the transformer is connected to your chassis, your ground, and then the two other leads of the winding on either side of the center tap go to the two plates on pin 3 and pin 5, I think it was. And the 5 volt winding goes through the filament. And then the filament becomes your cathode, and that becomes your positive lead. You put your capacitor across there. That's how the rectifier tubes work. Whereas what the person had done who modified this before I got the radio, what they basically did was they just took a diode, right? And they put a diode across like that. Left the tube in the circuit. And the tube itself shorted out completely. And when that happened, it killed the radio. It actually killed the diode as well, I think. Anyway, when I first did the repair on this thing to get it going, I cut the plates like that so the diode could operate. But I left the filament in circuit so that it would draw the correct amount of current from the transformer, just so that the transformer wasn't into an open load. Let the filament heat up, but I had no current going through the tube, so the filament would heat. It wouldn't cause any damage on anything. The only downside to this is that you're getting hammered with the full voltage as soon as it's turned on, versus the time it takes for the filament to heat up allows the voltage to rise gradually. So that's why I wanted to put it back with a tube in the circuit. So here's the original bad rectifier tube. Now that I've rewired the circuit, let's see what happens when I apply power. This thing should light up like a Roman candle. Oh, it's going to make a liar out of me. This thing was gassing like you wouldn't believe. There it goes. You see it glowing? We'll kill the lights. You guys will see the thing glowing.
Answer quick so you can talk to the big asshole.
Before I was so rudely interrupted. So that's the, as you can see, the original tube is no good. So we'll plug the new tube in I can even do this hot. I don't need to unplug the power. Other tubes are nicely warmed up, so when I plug this one in, as soon as it heats up, I'll get sound. There you go. The phone call I just got, I love my ringtone. See, that the guy that called me, he truly is. He truly is. So I'll say no more than that. Okay, now that I know that it works and it's not going to blow up, I'll take it off the dim bulb tester and give it full voltage. And we have a bass and treble control on here, as well as looks like a loudness and a volume control here. So I got it tuned into my little test transmitter now with my royalty-free music, so I can play this. Bass control, treble. I believe this has got an auxiliary input too, so we can plug a source into this and see how good this tube amp sounds. Now we can use it just as an amplifier. Both an audio, or both, sorry, it has both an auxiliary and a phono input. If I switch this plug to the other side and go to the magnetic phono input, you'll hear it's all distorted. If I turn this down, so it has both a magnetic and a high level input on the back here. Go back to the high level input and then turn up the volume. If only this was stereo, it would sound fantastic, just as an amplifier. Radio.
We're also working.
Now remember, I don't have an antenna on this. I have a piece of wire about 6 inches long.
We hope to launch.
Tuner's working pretty good.
Your 29th.
If I touch the antenna terminal, I'm sure it'll come in better.
Also 19 degrees on Ray Lachinea.
I think he overdo it and recommends about 5 on the bond.
Third, that is.
Alpine Credits. Home equity loan since 1969. Homeowners get it.
The kickoff is at 5:30. Meanwhile, on PC Place, the Vancouver Whites.
住咧，更加係要留意佢哋係要買呢個 insurance 啊，佢哋交易咗啲乜嘢，整壞咗啲乜嘢嘢咧。
Casey's gray pouch, or what is that thing, Casey? Clovis Slade was winemaker Michael.
You know, for AM radio, this has got to be one of the better sounding ones I've heard for just detecting AM. What I normally do here is for my little AM transmitter, because I like to listen to my old vintage radio, so I have an FM tuner going into it, so I normally put it on something else. We'll just switch some frequencies here and see how it sounds. Of course, I couldn't leave that on the other stuff for very long, but that's normally what I do. Is I have a little FM tuner board, and I just have it plugged into my little AM transmitter, and then I can just listen to whatever I want, because of course on AM there's not a heck of a lot on there other than talk. So I just put a music station on, and then I can listen to my old vintage radios. This one's not sounding bad. So this is a 9-tube radio. The two outputs, it's a push-pull, so it's going to have a little more power. Probably about 15 watts, I'm guessing. I'm guessing probably about 15 watts of power. Rectifier tube. Here's our IF tubes on here. This one over here, this is going to be a mixer, oscillator probably. Mixer, IF, detection, maybe an audio amplifier, and this one over here, that'll be the phono preamp for the magnetic cartridge. That's why it's shielded like that. Same with this one. This is going to be probably an audio tube as well. Anyway, thanks for watching. We'll catch you in the next one. Bye for now.